Hello, everyone, and thanks for joining me for my talk on the introduction to the NEAR Filecoin Bridge. Today, we're going to talk about a pretty cool way that you can get permissionless storage for your dApp or DAO or NFT or whatever project from NEAR to Filecoin. My name is Carson Farmer. I'm part of the team at Textile. And so at Textile, our mission is to accelerate the exchange of information across society. And so we think that keeping humanity's data safe means creating systems that promote the exchange of data and information across borders and through time. And so we're really doubling down on Filecoin as this means to safeguard humanity's data. As a result, we're pretty committed to getting as many bytes on Filecoin as possible, because we believe this is the most direct path to enabling every individual, organization, DAO, community to own, control, and preserve their data into the future. And so the way we approach development is that we build products as experiments to test assumptions about Filecoin and other protocols and networks and users. And we do this out in the open as much as possible. And we use each product to gather new data and then to sort of leapfrog our previous innovations. And so today I want to talk to you about one such experiment that's proving to be a pretty powerful open protocol or concept for enabling permissionless storage to blockchain users and their applications in their native token. And so we're calling this thing the bridge, or the Filecoin Bridge. And bridges make it possible for developers and their users to start storing data off-chain from just about any blockchain without any conversion, signups, developer tokens, or secrets exchanged. So the data is stored on IPFS and Filecoin. And so for those who aren't familiar, Filecoin brings a sort of incentive layer to decentralized storage with all of the benefits of the IPFS stack, like cryptographically verified data, peer-to-peer data exchange, deduplication, and all that good stuff. And so what we have really here is a means for dApp developers to easily and pretty seamlessly store user data, app data, NFT assets, and a whole lot of other stuff off-chain on a purpose-built storage blockchain like Filecoin, and then reference that data whenever and however they like in their native chain. So in a NEAR dApp or in a JavaScript React app or on the command line or wherever. And so we're building a Filecoin bridge to just about every blockchain we can get our hands on. And we started actually with NEAR, and now we also support Ethereum and Polygon with more blockchains to come. And really, bridges are just an open interface for providing off-chain storage to blockchain apps. So under the hood, bridges use an open Filecoin auctioning system that Textile developed to push data to Filecoin. What this means is that when you're using the bridge to push data from your native chain to Filecoin, that could be via an app or a smart contract, you still reference and retrieve data over IPFS like you normally would, but the raw data is also available in storage contracts created with miners on the Filecoin network. And so the metadata for that storage can then be reported back to the native chain as open and reusable building blocks that we all love in the blockchain space. And so the core Filecoin storage bridge revolves around kind of two key concepts: deposits and storage. So the deposits API, that all happens on chain in, say, NEAR. And that's this component here. Whereas the storage APIs, they all interact with off-chain storage via something we call a validator that interfaces with Filecoin. So that's this piece here. So validators handle things like compiling and batching and deal making with the Filecoin network, and then they report deal success back to the native chain. Along the way, data is cached in a highly available IPFS layer, while all the whole deal sealing and proving stages are underway for the Filecoin component. So this is pretty cool because that means that app users and developers have fast, off-chain, content addressable data available right away for their smart contracts, while the slower, provable, incentivized storage is making its way onto the Filecoin chain. Now, validators can provide things like indexing, mapping of CIDs, so the content for data that's pushed over the bridge, and more to on-chain apps and services. And the deposit component is really just a sort of Sybil resistance component, so that users looking to store data on Filecoin via a validator, they first have to deposit funds proportional to the length of time they'd like to continue storing data. And there are some defaults there, about a quarter near for 10 minutes, I think. After funds expire, they can be released by any user in the ecosystem just by making a smart contract call. It's pretty cheap. And this provides a way to release funds after a storage session has been completed without locking up those funds during the long proof process for Filecoin. And so once that deposit is available, the app user or even the smart contract who might be operating on behalf of a user, they can push data to the validator using an API endpoint that is available via the validator smart contract. That's right here. And then they can interface this off-chain REST API to push data for upload to Filecoin. The status of each storage request can also be queried via a REST API, so store and status. And that status can range anywhere from batching files together to preparing the storage deal to auctioning the data off to actually deal making and success on the Filecoin blockchain. Along the way, clients can query that at any time to get the status of their storage request. So digging a bit more into the on-chain components, we have two main contracts that you might want to think about if you're concerned with this sort of thing. So we have a registry, and then we have multiple on-chain validator contracts. So the registry is really just a logically centralized registry of validator contracts that support a really simple interface. It looks like this in sort of a assembly script interface. And it really just needs to expose a registry for adding, deleting, and listing validators. And only the current owner of the contract can mutate the registry, but any external caller can query it. And so we're actually actively working on some governance structures so that we'll actually be able to have like a multi-sig or DAO-based way of actually deciding which validators make it into the registry and which don't. And so if you're at all interested in that, please do get in touch because we'd love to have more folks involved in that. And I can talk about that at the end of the talk here. The validator contracts, they're similarly pretty simple interfaces, and they can be implemented by anyone that wants to run a Filecoin validator node, or rather a bridge validator node. The core interface looks like this. And unlike the registry, it doesn't require that the contract is, owned by anyone in particular, but there are a few sort of key API requirements, including the API endpoint and adding and checking and releasing deposits. We also provide some logging functionality so that you can watch for sort of events in the logs of smart contract calls. And that just makes it a little bit easier to do things like interact with events. And I'll talk a little bit more about that in a moment when we talk about some features that we've been working on with the graph. So how can you leverage this sort of bridge system for storing off-chain data? Well, if you're a smart contract developer, then you might want to just try making some cross-contract calls, deposit some funds from your dApp for your user or have your user do it, any way that you'd normally interact with a smart contract. We've also started integrating with the graph, as I mentioned, for indexing some of the contract logging events so that you can actually build expressive dApps that monitor Filecoin storage requests on Near, which is a pretty amazing superpower. And if you're at all interested in that, pay close attention to what the graph team is bringing to the Near ecosystem. But if smart contracts aren't your thing, then Textile's Filecoin Storage Bridge also provides some TypeScript or JavaScript SDKs that make it really easy to store data on Filecoin from any blockchain-based app, but in particular from Near. So we have a JavaScript library called near.storage, and that should feel really comfortable to any developer that's already familiar with the sort of common Near JavaScript libraries that are available. And it provides a pretty small but useful API that basically covers all of the functionality that the smart contracts do, but it wraps it up in a nice JavaScript SDK. So really, you end up just having to import the library, have your user or deposit some funds, or your dApp can do it directly, and then they're ready to start submitting data to the Filecoin network right away. So if you're all interested in playing around with this, you should definitely check out our docs at near.storage. You can check that out. We also have a demo, storage JS basic demo, that allows you to actually, you can take a look at the demo. It's a simple React app, but it's also deployed live so that you can interact with it and deposit some funds and upload some files. And I'll actually show you an example of using this in a little demo later. Now, by the way, I should mention this whole bridge system is actually being made free for the foreseeable future, thanks to support from a bunch of the awesome folks at Filecoin and Near, and also the Polygon ecosystem. So, there's really no barriers to trying this out. Storage is free, and when you leave a deposit, you get the full deposit back afterwards. So if you're interested in playing around with the JavaScript SDK, it's pretty simple. Just a couple of normal imports that you'd always expect up at the top, and then one extra one to initialize the Near storage SDK. So normally you do your normal connect to your Near, the Near testnet, for instance, create a new wallet connection instance, request a sign in, and maybe you'll stick your wallet or your smart contract address here. And then you just simply initialize based on the wallet's account. Now you get back a storage object, and that storage object pretty much reflects all of the APIs that are available on the in the validator contract. So for instance, we might create some data. This could be from a user's drag and drop event, or you might create some file. Maybe it's an NFT asset. You can simply add a deposit and wait for that to go through, and then store the file. What you get back is a storage request ID and the CID or content ID for that data. At any time, you can get the status of your storage request by calling storage.status. You get back the request and any of the deals, the Filecoin deals that data is associated with. Now, if you've just pushed something over the bridge, it's probably not available in any deals yet, but it should be on its way to batching and being put into storage deals pretty quick. After that, you can call storage.release deposits if your session has timed out, and then you might want to sign out of your wallet or whatever sort of user interactions you might want to provide. So with the time remaining, I wanted to go through a quick demo that goes through cloning, building, deploying, uploading, and minting a simple NFT using some of the components of the bridge. And so we can jump over to a Notion document that I have available. So for those folks that are watching at home, they can go through at their own pace. So before we jump into that, I just wanted to make a quick thanks for following along. I mentioned that we're always hiring, so get in touch if you're interested in any of this type of stuff. And without further ado, let's jump into the demo. So the demo is available via these slides here. And we're going to just go through, and I'll go through the steps with you now. So what we're going to do is create a NFT using Near's standard NFT contract. And so what you can do is if you're working from the command line, you might just create a new demo folder and move into it, and then clone the Near examples NFT example. Now, this is a Rust contract. So for those who are familiar with Rust, you can sort of dig in there and play along. If you're not familiar with Rust, the good news is you really don't need to know anything about Rust to play around with this. So all you need to do is just make sure that you can build the contract and then set up the tooling to do that. So make sure that Rust is installed as per the prerequisites in the Near SDK Rust. And you can go to that GitHub link if you want and check that out. And then make sure that you have the Near CLI installed. And you can do all that stuff at once by running these commands. So with those two things out of the way, it's really pretty easy to build that NFT contract. So you could just call build.sh. Now, I'm not going to bother going through all the tests and things like that right now. You probably should do that yourself. But we're just going to do a quick deploy today into a throwaway dev account that you can just play around with. But then what I'll do is I'll actually transfer my NFT to a real testnet account to see how things went, and so that you can actually view the NFT in your testnet wallet. So if you follow this code here, you can do a near dev deploy using the near CLI and specify the NFT WASM file that you just built. You also want to specify the helper URL for the contract helper, and that can all be done there. Behind the scenes, this is actually creating a new account and deploying a contract to it. And on the console, you'll see a message, a bunch of text, and then it'll finish off with something like this. In my case, the account is this very long random string here. Yours will be something different. On your system, a file has also been created containing a key pair for this account, and it should be in your local folder here, near dev account. So to make the next few steps a little bit easier, you can actually just source that .env file, and that will just add a few environment variables that make it a little bit easier to reference things. And so you can check to see if that environment variable is available by just echoing the contract name. Okay, and you can check to make sure that it prints the account name for this contract, which we just looked at. So then what we can do is we can initialize the contract using the new method. So near, call that contract name, new default meta, and I'm just going to specify the owner ID is the contract name, and the account ID, similarly, the contract name. We can take a quick look at the NFT metadata by calling near view and calling the NFT metadata method on that particular contract. So now what we'll do is we'll actually mint this NFT. But we do kind of need some sort of asset associated with it. Otherwise, it's just an empty NFT and it's not very exciting. So I'm actually going to use the Filecoin Bridge to near to deploy our asset to IPFS and Filecoin. And the really cool thing here is that means we've got a content addressable, verifiable asset on IPFS and Filecoin that we can reference in our NFT for a truly secure and strong NFT implementation. And so this is one of my favorite GIFs. So we can use that as our NFT asset. And we could do this from the terminal, or maybe if you're a developer, you might use a JavaScript script to actually leverage the SDK and do this as part of your deploy step. But to keep things kind of simple and visual for our session here, I'm just going to use our existing bridge demo and React app to upload the file manually. So I'm going to click on this, and here is our bridge demo, which you can definitely check out on GitHub if you're playing around with it or interested. But you can also just click on the live demos here button, and we're going to stick with the near demo. So if I do that, and I click on the near storage demo, I'm going to go ahead and log out just so that I start fresh. And this is going to automatically pop up a new login, so I can choose a near account that I want to use. So I will go ahead and I'll use init.testnet, and I'll allow that. It's just an account that I have on testnet. And then I'll deposit some funds. I'm going to go ahead and give it a quarter near. Wait for that transfer to happen. And now I'm going to upload my NFT asset. And it happens to be right here. Open that, and I'll click upload. And as that goes, we'll get back my CID. Okay. And I might want to copy that CID so that when I jump back to my steps here, we should end up with a CID. And since I'm uploading the same data that I've done before, I should end up with this same CID. Now I'll need to compute the base 64 encoded string of this hash to use in the media hash key of my NFT metadata. And so I can use a command line tool to do that. And then I'll just call the contract name and mint that and specify all of this information in my NFT metadata. And so if you want to take a look here, I put the CID of my uploaded file as the media URL. And then I also include the media hash as a base 64 encoded string. And then what I can do is I can actually transfer the ownership of this NFT to some account that I own so that I can actually view it and enjoy it and check it out. So thanks again for joining me, and we'll see you next time.